up to this point, we've only found the derivatives of monomials, but it turns out that you are allowed to take derivatives across the sums and differences. Not across multiplication and division of variables, but you are allowed to take derivatives by utilizing the power rule across things other than monomials. So like binomials and trinomials, and so on and so forth. So the sum and difference rule states that derivatives can be found across addition and subtraction by differentiating one term at a time. So, for example, if we have f of x equals x cubed minus 4x plus 5, we can take the derivative by breaking that into 3 different problems and taking the derivative of x cubed, taking the derivative of negative 4x, and taking the derivative of positive 5 individually by applying the power rule each time. F prime of x is going to equal, what's the derivative of x cubed?
3x squared.
3x squared. Power times coefficient is 3 times 1. Down 1 on the power gives me 3x squared. So we're finished with the x cubed. Now we're going to take the derivative of negative 4x. And we learned that if we have just x to the first power, that it just leaves its what as the derivative? Its coefficient. Yeah, it will become a constant, right. Because that's the same thing as 1 times negative 4, and then x to the 0 power. And the 0 power just becomes a 1. So the derivative of negative 4x is just negative 4. What's the derivative of positive 5?
0.
5 is a constant, so the derivative is just 0. Because you could think of 5 as 5x to the 0 power, and 0 times 5 would be 0. So that's why it works. So the final answer is just 3x squared minus 4. And this really opens up like what we can differentiate. So let's take a look at g of x equals negative x to the 4th over 2 plus 2x cubed minus 2x. It will help me if I rewrite this as negative 1/2 x to the 4th plus 2x cubed minus 2x. I have to be able to see it as like a coefficient and then times a variable to a power. So I don't do well when like it's stacked over the 2 that way. So if you rewrite it as a coefficient, you should be able to differentiate this one pretty easily. We have g prime of x is equal to, what's 4 times negative 1/2? Negative 2x to the 3rd. So we're finished with the first term. And then positive 3 times positive 2 is positive 6x to the 2nd. And the derivative of negative 2x is just negative 2. That's it. So we have negative 2x cubed plus 6x squared minus 2. That's our derivative. For this problem right here, until you're told otherwise, and we learn something called the chain rule, you need to get rid of all parentheses before you try to take the derivative. So what are we going to have to do here? Square double square. So we're going to need to distribute out that binomial squared. We can apply square double square and get 9x squared minus 30x plus 25. And once you get to here, you can start your calculus and take the derivative. So we have y prime equals 18x minus 30 plus 0. So we'll pause right there and see if you have any questions. We are also going to memorize the derivatives of our basic trig functions. And so we're going to split those up so you don't have to do them all at once. So the first 2 we're going to memorize are the derivatives of sine and cosine. And this has nothing to do with the power rule. Trig functions are completely separate. We're just going to start introducing them so we don't waylay you with them all at once. So this does not have to do with the power rule. You have to memorize these. You need to go ahead and memorize that the derivative of sine is cosine, and the derivative of cosine is negative sine, as long as the variable is just a plain variable, plain x or plain t or plain whatever. It can't be like 3x or 5x. So these are only for the most basic trig functions. So the derivative of sine is cosine, and the derivative of cosine is negative sine. So let's see what it looks like to use those a little bit. If I want to find the derivative of y equals 2 times sine of x, because it's a trig function, a basic trig function, one of your basic 6, okay, you do not use the power rule at all. It has nothing to do with the power rule. Well, it kind of does, but until you know the chain rule, I can't explain to you the connection to it. So for now, you're just going to have to trust me that when it's a trig function like this, just sine of x to the first power, no coefficient on the x, that you simply keep the coefficient and take the derivative of the trig function. So the derivative of sine of x is cosine x. So there you go. That's your derivative. The derivative of 2 sine of x is 2 cosine of x. For part B, we have f of x equals 3 sine of x all over 2. It will help you if you look at that instead as a coefficient times sine of x. Because it is one of our 6 basic trig functions, you don't apply the power rule. You simply keep the coefficient, which is 3/2, and take the derivative of sine, which is cosine. Now, if you'd like, you could rewrite it as 3 cosine x over 2, but I always prefer to have my coefficient out in front. It's up to you then. So now we're allowed to take derivatives of things that are strings of terms added and subtracted, but also include trig functions. So let's look at part C, which says g of x is equal to x plus cosine x. G of x is equal to x plus cosine x. If we take the derivative, we're going to do one term at a time. What's the derivative of x? 1. Just 1. What's the derivative of cosine of x? Negative sine of x.
What is that? That's not
So the derivative of x plus cosine x must equal 1 minus sine x, because the derivative of x is just 1, x to the 0, so just 1, and the derivative of plain positive cosine of x is negative sine of x. So technically it's 1 plus negative sine of x, but anytime we have plus and negative, we just write minus.